Good morning, everyone. This is Shauna, and I'm coming to you with another section walkthrough. Since the section walkthrough for 3.2 was so helpful to some of you, I've decided to do a similar project with section 3.1, where we discuss the measures of central tendency. Hopefully, I can dispel some of the mystique around that. So let's get started here. Let's take a look at the homework. So, oops, the answer key is not going to help us much if we don't know what's on the homework. So let me scroll back. So this homework focuses heavily on these key terms: the mean, the median, the mode, and the mid-range. The mean is the one that you're probably the most familiar with, that you might have come into this class with a knowledge of. It's the most likely one. The mean happens when we have raw data like this, like in number 1. The mean is where we add everything up and divide by how many numbers there are. That's what the mean is. The median is the middle number when they're ranked in order. The mode is the most frequent score, and the mid-range is the minimum plus the maximum divided by 2. I'm going to use the calculator to assist me with sorting some of this data, and then I'll show you where some of these numbers come from. To save some time, I've preloaded the calculator with some of these lists. I pre-populated the data for number 1 is in list 1. So what I've done here is I've put the data as you see it on the homework into list 1. I just put all the values in there. So you put in a value, you hit enter, you do that till you get to the bottom of the list, okay? What you want to do to help yourself with these problems when you're using the calculator is you want to sort the data. It's not going to change the mean. It's not going to change anything else, and it's going to help you when you get the median. So I'm going to take just L1 here, and I'm going to sort L1 in ascending order, which means I'm going to sort it from the low to the high. So to do that, I'm going to go to stat. Here on the screen, I'm going to go to stat. I'm going to go to sort A, and especially since I have more than one list, I'm going to specify L1. Now, L1 is on top of the number 1 key. So I'm going to hit second L1 here, and I'm going to close. And what that's going to do is that's going to sort for me. So I'm going to go to stat again and either enter or the number 1, either way. And you'll see that just L1, because that's all I asked it to do, just L1 has been sorted. Okay, so there's L1, and you can see the values in the list. Now, let's go through the measures by hand and see what we can see here. So let me bring up the whiteboard, and we'll start doing some calculation. All right. So when we want to find, okay, so this is problem 1. Okay. And you want to find the mean, the median, median, mode, and mid-range. Okay. So let's do that. Now the mean, okay, so the mean here has a symbol, and the symbol for the mean is X bar. I'm going to write X bar next to this. And the way we get the mean, as I mentioned before, is to take the sum of X and divide by N, which is the number of values that we have. So that's going to be, now, this is where this comes in handy. Remember, we're doing it by hand. Now, there's ways to get the sum. So I'm going to go ahead and you're going to write, to show your work on this first exam, you're going to write out the first few values of the data list. Doesn't have to be, I mean, this has a lot of data, but we just want to know that you know what you're doing. So if I write 590 plus 605 plus 700, okay, plus 730, and so we're going to have this is, okay, this is 590 plus 605 plus 700, right? Plus dot, 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 dot means it goes on. Then what you can do is you can pick up the last data, 605, 700. So now you can pick up the last data value here. Remember, to get to the bottom of your list, you can go up arrow to L1 here, and then you can down arrow, and that will give you the last number in your list, which is 1595. And we can tell also from our list, go to your last list element with a number in it. This 25 tells you how many numbers there are in the list. So we're dividing by 25 here. Plus, that gives me this. So let's go back and I'll show you. So we have this is 1595 at the bottom, at the back. This is 1595. Okay. And then you have 25 down here. Okay. Now we're going to add all of the top numbers, and then we're going to divide that by 25. Now, if you want a little pointer, there's nothing wrong with here. There's nothing wrong with going to the calculator here and going to one var stat, which I've shown you in a previous video before. I showed you this in 3.2. But if you haven't seen it, you go to stat. You right arrow to calc, because we want this second word on the very top menu. You go to one var stat. Okay. You tell it which list name you want. Okay, we want L1. We do not want a frequency list when we have ungrouped data. So I'm going to get rid of L1 here. I'm just going to put the list. I don't have a frequency list in there, and I'm going to calculate that. Now, this actually tells me what the mean is. It's 994.6, but the way we get that is with this sum of X that's on the second line to 24,865. So here we do, this is 24,000. This is equal to, this is 24,865 And we're dividing that by, oops, 25. So this is 25 because there are 25 data. And that division comes out to be 994.6. Now, let's go back. Now, remember, for this exam, you have to show this work, okay? So you can put it in the calculator, you can help yourself with that, but you still need to show this work on this exam so that we know you know how to do the material, all right? So let me go back and I'm going to do one thing here. I'm going to go to my calculator. Okay. And I'm going to do 28,000. What was it? Hold on. Let me come back. It wasn't 994. It was 28,000 something. And I forgot to take note of the number. Let me come back to it. 24,865. So here I have 24,865 divided by 25. Hit enter. There's your mean. That's 994.6, which agrees with what we saw on the screen. And if you look at, excuse me, if you look at the homework here, scroll down to the 4th page, I think it is. You see that the mean is 994.6. Okay. Now we're going to do the median, the mode, and the mid-range. So now we're going to go back to our calculator here. Now the median, there's a few ways to get the median. And this may or may not agree with your calculator. Sometimes it doesn't. Most of the time it does, but sometimes it doesn't. The way we're doing it here with raw data is, this is why you want the list to be ranked, okay? Let me show you what the PowerPoint slides have you do. So let me go back to the, hold on, let me move this out of the way. And let me scroll up. So this is our, now when you're doing the median, okay? What we want to do is find the middle number. Now, sometimes, as in this example, let me make sure that I'm sharing the correct screen. Let me go back to this. Sometimes we can write the data out and sort the data here, and then use the middle answer, the middle number. But usually what we do is we use what we call our location. So what we do is we count the amount of elements we have, okay? Because remember, the median depends on how many numbers we've got. So here we want to look for our middle number. So we're going to take the number of elements we have and we're going to divide it by 2. All right. So here's how this works. Let's go back to our calculator data for a minute. We know that in L1, we're doing, this is 25 elements, okay? So we would like to know where in this list our median is and what is it. So I know here that I have in this case, I have the median is what? Okay, well, we'll find out in a minute. Okay, well, I know that I have 25 numbers in my list. So one of the ways I can do this, since my list is already sorted, I can find the location of my median in the list. So what I'm going to do there is I'm going to say this. I'm going to say that my location L is equal to n plus 1 divided by 2. Okay. Now you take your data, and here's the thing. If you have an odd number of data points, let me just show you. If we just had, I'll come back to that in a minute. Suppose our list were 600, 700, and 800. Okay. Now that's pretty easy to find the median. We just cross out the lowest, cross out the highest, and bang, there's our middle number, there's our median. Whenever the list has an odd number of elements, this has 3 elements, okay? What you can do this anyway, but it's always the middle number. So here you'd have 3 plus 1. Do that sum first and then divide it by 2. This is 4 divided by 2. And so your location of the median is the second position. This means that in this case, the location of my median is the number that's in the second position, which happens to be 700, which it is. Okay. That works when your list has an odd number of elements. It also works if it's even, but let me add one other thing here. Let's say that I have the same list, but I'm going to add a number, 600, 700, 800, and now I'm going to add one more. I'm going to add 900. Okay. If your list has an even number of elements here, n is 4. N is 4. Okay. This data, we do the same thing, but we end up with 2 middle numbers instead of 1. When you end up with 2 middle numbers, you have to average the 2 middle numbers that you're going to get. So what position do you need to be in? Well, take n over 2. This is, let me show you, this is n plus 1 over 2. So now here, this tells you that you're in the, this is 4 plus 1 over 2. That's 5 over 2. Remember, this is a location. It's going to be a decimal answer. This is 5 over 2, which is 2.5. So this is going to give you 2.5. What does that mean? That means that your median is in the 2.5 position. Well, this is position number 2 right here. This is position 2, and this is position 3. So your median is right in the middle of these two numbers. Your median is here. Now notice your median is not going to be on your list, but you can find what the median is. So in order to calculate your median in this case, you're going to say 700 plus 800 divided by 2. And that would be 1,500 divided by 2, which is 750. Okay, so if you have an even number of elements, I'm sorry, an odd number of elements, if you have an odd number of elements, 3, 5, 7, 9, so forth, your median will be a single number right in the middle of your list. If you have an even number of elements, then you're going to have two middle numbers that you're going to average. So how does that apply? Let's go back to here, and let me show you what she said. So here, now, if you look at the sorted data here, how many data values do we have? Well, if we look at our list here, we have in this example, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 values. That's odd. So I'm going to add 1. 9 plus 1 is 10 divided by 2. That's 5. So the location of your median is the 5th position in your list, in your sorted list. Okay, it's the 5th position. So if that's the case, then we're going to count 5 numbers over 1, 2, 3, 4, 5, and your median is in this 5th position, 124. Okay, that's where she's getting the median from. If you happen to have an even number of elements, then you have n divided by 2, but that's how we do it. Okay, so let me go to the problem that we're working on actually. Let me go to that data. Go to the whiteboard for our data here. Go back to our first whiteboard, okay? Now, remember, I don't have all the numbers in here, so I'm gonna have to go to the calculator to do it. But I do know that I have 25 elements, okay? So what I can do here is I can say, well, all right, I'm gonna say I have 25 elements because there were 25 numbers in my list. So this is going to be 25 plus 1 divided by 2. Okay. And that's going to give me 26 divided by 2, right? And that would give me 13. This is 26. And I'm dividing it by 2. So I'm going to do that. And I'm going to divide it by 2. And I'm going to end up with 13 as my position. Now, what does that mean? That means that if I go back to the calculator here, that I'm in the 13th position, okay? So if you go on your calculator and you see the counter moving in L1, find the number in the 13th position, it's 940. That's your median, okay? Your median is 940, okay? So on your paper, you would write the numbers out in order, and then you would say, well, I have in the 13th position, I have 940 as my median. You would have to write this out on your paper in order for us to be able to verify your list. Okay, so you'd write the whole list out and then you would do that. So here, let's go to the homework page. All right. So we have, whoops, let's go to our homework. And you can see that 940 is our median. Okay. Now, the next thing to get is your mode. Now, your mode is the score that is the most frequent. It repeats the greatest number of times. So here you want to look at your list and you want to pay attention to the numbers that are repeated. So there's a 590, it doesn't repeat. 605 doesn't repeat. 700 doesn't repeat. You want to pay attention to anything that's repeated. And what I'm noticing here is that, okay, the first number that I see repeated is 1180. As I've been scrolling, you see how there's two 1180s in my list. Now, I'm going to see if there's another number that repeats more than twice. 1260, no. So the only number that repeated was 1180, okay? Doesn't matter how many times it repeats, as long as it repeats more than the rest, okay? So the mode here is 1180. So if you look at the homework here, your mode, give me a minute. Okay. Your mode is 1180, and it is. Okay. So if I go to my screen share here for the whiteboard, my mode so here, my mode was, sorry, let me fill this in. My 13th position in the list was my median, my MD was, what was it, 930, I think. I didn't write it down, I should have. It was 940, okay? So my mode, my median rather was 940. So this was 940 from my list. Now, my mode was 1180, and it repeats twice. You don't have to write repeats twice, but I'm doing it here to remind you that it repeated more than the rest of the numbers. Now, the only other thing we have to get for this problem is the mid-range. In mid-range for this, the mid-range for all the problems is the minimum plus the maximum divided by 2. Okay, you want to make sure that you add both and divide by how many there are. So this is going to be MR here for this problem will be, our smallest is 590. Our largest is 1595. And if we add that together and then divide the sum by 2, 590 plus 1595, you get 590 plus 1595. That's 2185 divided by 2 is 1092.5. Okay. Now, this is 1092.5. So this is equal to 1092.5. And that's our mid-range. Okay, so that completes this problem. All right, so here, this is the work that we show for our problem 1. Now, a lot of these problems are similar in the homework. So if we go back and look at the homework, okay, I did problem 1 with you here, if you were following along, okay? So problem 1 should be done now. Problem 2, 3, 4. Now, number 4 is going to require 2 sets of these. There's only 4 data values, not 8, okay? You need to do 1 for the first column of data because that's the diameters of the moon with how far apart they are, okay? So you either use the kilometers or the miles, but you don't put all 8 of these in your calculator. This, like for example, 3,643 kilometers is 2,264 miles. So use 1 set of data, okay? If you want to do the problem twice, you can convert from kilometers to miles, but that's why they're given twice. One of these is kilometers, one of these is miles. So you do the same thing. There's only 4 data values, okay? And then it says discuss which of these measures have any meaningful application with respect to these data. So if you find, for example, that, whichever one is furthest from the mean, for example, would be the furthest out, or whatever the median distance is, they average about this much distance out, something like that. They're asking you to make a comment about the data. Your answer will vary. You may have a different answer than your classmate. Number 5, same routine, same procedure. The first 6 problems follow the procedure in number 1. So if you can do number 1, you should be able to get all the way to number 6 by yourself, okay? 1 through 6 follow the same procedures that I just showed you. Number 7 is where we get into group data, okay? And again, you can be given class boundaries or class limits, okay? Now, we're going to be talking about the mean. Obviously, we can find the mean for group data like this. We can't find a single mode. What we can find is what we call the modal class, which is, remember, the classes are the rows. So for example, let's look at number 7 here. We have, let me come back to the slides for a minute. So here, we're going to calculate the mean for group data. Here's my formula. We're going to take the sum of the frequency times the midpoint and divide by how many numbers there are, okay? And if you want to use the calculator, it's there for you. So here, she says use a graphing calculator, okay? This is going to be similar to what you did with ungrouped data in 3.2 when you were using the graphing calculator for that, all right? So here's what we're going to do. Let's go back to our homework here. Let's do number 7. Now, what we need to do is we need to find the midpoints. So if you remember how to find midpoints, we always find midpoints roughly the same way. We're going to add ourselves a column in the table. Okay, we're going to call it midpoints. And we're going to add up the lower boundary, the upper boundary, and divide by 2. So 0.5 plus 3.5 divided by 2. 3.5 plus a half, that's 4. 4 divided by 2 is 2, okay? Same thing here, keep going. So we have 3.5 plus 6.5, whoops, divided by 2. Oopsie, let me type correctly. There we are. That's equal to 10 divided by 2. That's 5. Okay. We keep going. We get 6.5. 6.5 plus 9.5 divided by 2. We get, this is 16 divided by 2, that's 8. And if you'll notice, they keep increasing by 3 units. So we would expect the next one to be 11. Let's see, 9.5 plus 12.5 divided by 2. This is 22. So this is 11. And finally, this one is 12.5 plus 15.5 divided by 2. That's 28, so that's 14. Those are my midpoints. Now, what do I do with that? Well, this midpoints, this is going to be your L1, and the frequency is going to be your L2. So your midpoints are going to be in L1, and your frequencies are going to be in L2. Now, I'm going to go ahead and give you a moment to work on that while I scribble down frequencies for our next step. All right. So it's our frequencies are 11, 12, 4, 2, and 1. And our midpoints are 2, 5, 8, 11, and 14. So this is our midpoint. Okay. Now, if you remember, I told you that when we deal with raw data, like we did in the first 6, we don't worry about a frequency list. But when you have group data like this, you do. So let me switch the screen to the calculator now and show you what we're going to do to find the mean of this data. So let me now, okay, stat, right? Edit. Now, here, I don't want all of this data in here. So what I'm going to do is I'm going to use this other trick that I showed you. You can clear them individually, but if you have multiple lists in your calculator, you can go second, which is under the Y equals key next to mode, second, memory, which is on top of the plus sign, and number 4, clear all lists. Second memory, number 4. Then hit enter. And then if you go back to stat, you hit number 1 or you hit enter. Now your lists have disappeared. I can make a new list now. Remember that my midpoints are in L1. So I'm going to put my midpoints in L1. This is 2, 5, 8, 11, and 14. And my frequencies for those midpoints in L2. So 11, 12, 4, 2, and 1. Okay, so those are my frequency. Now, I'm going to go to stat, going to go to calc. I'm going to go to 1 var stat, enter. This time I'm going to have my list as L1, which it already is. But when I get to frequency list here, I want to enter L2 as my frequency list. Again, because L2 is on top of number 2, I'm going to go second, number 2 right here and calculate that. And if you look, you have a mean, you have a sum, you have a squared, whatever you have. Your mean here is the first element on your list. This is your X bar. So your mean here is 5. Okay, so 5 is the mean of this distribution. So here I have, let's go back to your data. Okay, then what this means is that 5 is going to be my mean, and this is number 7. So I'm gonna, the other thing we need to find is what we call the modal class. For the modal class, just like the mode, you're gonna look for the most frequent score. So we're gonna look in this column, we're gonna look for the most frequent score, which is 12. And our modal class will be the boundaries that are there. So the modal class here is 3.5 to 6.5. And the mean, as we previously discovered, is 5 units. Okay, so I'm going to scroll down and show you that. All right. So this is, oops, number 7. You see that it's 5 and your modal class is 3.5 to 6.5. Now, that procedure that I just showed you applies to the grouped data, okay? So the procedure that I just went through for number 7 will apply for number 7, number 8, number 9, number 10, and number 11. Now, when we get to 12 to 14, we have another concept here, okay? 12 to 14, we have another concept, and that is this idea of the weighted mean, okay? Because this is probably a little bit different than what you're used to. A weighted mean is when you still add everything up and divide by how many there are, but not everything has the same weight or the same bearing on the final answer. So we have a formula for that. Let me show you that. Okay. Let me show you the slides here. Now, the slides for the weighted mean are start with number 20, all right? And as you can see, it says X bar is the sum of the weights times the variable X on the top, divided by the sum of the weights down below, all right? So now, you are taking a class in which your grade is determined from 5 sources. The information is given below. What is the weighted mean of your scores? If you see the problem worded this way, weighted mean of fill in the blank. Here it's your scores, and she highlighted the word. That word that comes after of is going to be your X. Weighted mean of X, and that's going to help you decide which one should be the weight and which one should be the score. That's the hardest part of this. Generally, if there's a percentage, you're going to convert it to a decimal. I'm going to show you a couple of these problems because a couple of them gave some students some problems. So we're going to take some time to go over this. All right. So here's my first question. Question 12. All right. it says, find the weighted mean price of 3 models of automobiles sold. So we have model ABC. We have model ABC. We have number, the number was 8, 10, 12 respectively. And the price was 10,000, 12,000, and 8,000. Okay. That's your, okay. So here, we're going to start our calculation by multiplying the price by the number by the number by the price. Then we're going to divide by the weight. Well, what is the weight? Find the weighted mean price of the model. So we're looking for the weighted mean of each of models. So we're going to divide here by the number that we have. All right. So let's show you that here. Let me put up the data on the whiteboard. Let me get another whiteboard here. Okay, so here, this is number 12. All right, so this is problem 12. And it's a weighted mean problem. Okay. Weighted mean. All right. So you have models. You have number. And you have price. So I'm gonna bear with me a moment while I make our table. Price here. Then this is model A. And there are 8 of those. And they sell for $10,000 each. 10,000. Then you have model B. There are 10 of those. They sell for $12,000 each. And then you have model C. There are 12 of those. They sell for $8,000 each. Okay, so the way you approach this weighted mean problem is the model letters we don't care about. It's just a way to distinguish the numbers. So our weighted mean formula, as I had shown you before, is the weighted mean, which we show with kind of a tilde on our X instead of a straight bar. We have a tilde thing. That's our X. This is our weighted mean here. And this is going to give us the sum of X times W, sum of XW, divided by the sum of W. Okay, so you can see how critical it is for you to be able to know which column is the weight, because if you miss this, you'll mix up the problem. So here, what my calculation looks like is the following. We have 8 times, I'm going to use the star for times, 8 times 10,000. and I'm going to leave out the commas, plus 10 times 12,000 plus 12 times 8,000. Close it. I'm going to move this over so it doesn't look like the denominator to you. And that's my top number. Now I'm going to divide that by the sum of the weight, which in this case is going to be the number of models I have. Find the weighted mean price of the models, So that's the models is my X, okay? And I'm going to divide this by my number. So I have 8 plus 10 plus 12. Okay, so now we're going to do this calculation on the calculator and put in our weighted mean here. So we have the following. This is, I'm going to clear this out. All right, so I have 8 times 10,000, 1, 2, 3, plus 10 times 1, 2, 3, plus 12 times 8,000. 1, 2, 3. That's the top. We're going to divide that. Notice that if you put this all in at once, you need parentheses around the top and the bottom. 8 plus 10 plus 12. And my weighted mean price is 9,866. Since this is money, we're going to round it to 2 places after the decimal point. $9,866.67. 9866.67. So this is $98.66.67. And this is my weighted mean price. So here, my weight was actually, my weight was here, and my X was here. Weighted mean of the price, So that was my X. So the other number was my weight. All right. That's how that went. Problem 12. All right. Let's look at here. Let's look at 13. All right. A recent survey of a new Diet Cola reported the following percentages of people who liked the taste. Find the weighted mean, what does it say? Of the percentages, okay? So these percentages are going to be my X, all right? Which means that the number surveyed is going to be my weight. Find the weighted mean of the percentages. So We're going to do something similar here. This is area favored and the number surveyed. So, all right. We're going to do 13 here. We get another whiteboard. This is problem 13. This is another weighted mean problem. Problem 13. Find the weighted mean of the percentages. So here we have our data. We're going to have a little table here. So we're going to have our area, our percentages, and then our whatever they called that, which I don't remember. So let me go back and look. This is the number surveyed. Okay. So here, this is going to be the number surveyed. All right. So number survey. Now, do we have area 1 here? The percentage, I believe, was 40, was it? We'll find out. And I believe this was 800 people, if I'm not mistaken. Otherwise, I'll have to undo this and see what happens. Oh no, I think this was 1,000 people. Let's share the screen and find out. So this is 40, 30, 50, 1,000, 3,000. Yeah. Okay. So okay. We're going to do the same thing here. This is one that this is going to be, move this out. Move this out. So this is going to be area 2. And we have 40. Oops. My apologies, folks. 40, 30. This is going to be 3,000 here. And then we have another column, another row, I should say, which is 50, right? Let me check that before I, yeah. Okay. And so you have 800 in there. So we're going to get 800 in here. Now, this looks a little suspicious because these percentages add up to more than 100. So I'm going to do this problem and see if it comes out the way it should, because I think these percentages should add up to 100, but maybe there's a reason why they don't. But anyway, find the weighted mean of the percentages means that this of the percentages here means that this percentage is my X. So these are my X's. These are my X's, and these are my weights. Okay, this is the weight of it. And again, we're going to do the weighted mean down here. This is going to give me 40. Now, chances are we convert this percentage, as I said, to a decimal. So we're going to do 0.40 times 1,000 plus 0.30 times 3,000 plus 0.50 times 800. 800. And I'm going to divide that by the sum of the weight. So we have 1,000 plus 3,000 plus 800. So if we do that calculation, you're going to get, this is 400, this is 300, so I mean 900, 400, so 900 and then 400, right? So I'm going to go ahead and put this in my calculator now. 0.40 times 1,000, 0.30 times 3,000, and 0.50 times 800. So going to this 0.40 times 1,000. 30 times 3,000 plus 0.50 times 800. The numerator is going to give me 1,700. Now, I'm going to divide that by my weights. So this is 1,700 divided by the weights, which is the sum of the weights, which if you add those up is 4,800. And if we then do the math one more time, we get, okay, we have 1,700 divided by 400. So let me see if that's the answer they have in the, let me see if that is it, because it makes me slightly suspicious here. So, scroll down, that was 12. And she doesn't have an answer to it. So I'm going to have to check with her and see. But that's how I would do it. Okay. So if you're having problems with that, then hold off on that and I will get back to you. Okay. But I hope that this walkthrough has helped you some. This situation here. So the first 6, as I said, are ungrouped data. Okay. And they follow pattern number 1. The second group, 7, 8, 9, 10, and 11 are grouped frequency distributions. They follow number 7. 12 and 13, we did 12 together, we did 13 together. They are weighted for you. They're weighted means, and then 14 and 15, you have a chance. You have another weighted mean on 14, and you have the situation. These number 15 is primarily vocabulary. All right. So the most typical case, if you're looking for generally the most typical case that you're looking for, that's going to give you the one that repeats the most time, if there is one, and that's going to be the mode. Okay. The typical case is going to be the mode. The distribution is open-ended, meaning that maybe it starts, maybe it's like 30 or more, right? If the distribution is open, you're going to need a median for that. Okay. If there's an extreme value in the data, again, there's another reason to grasp for the median, because the median will minimize the effects, the pulling effects of those larger, those small scores. If you've ever been in a class where, everybody kind of did okay, but not great, but then you had somebody that got a perfect score, that perfect score pulls up everybody's curve, right? Pulls up the total for the whole class. And that's a median is less resistant to that, but a mean is very fluid and very much influenced by extremes. So if you want to minimize the effects of extreme values, use a median, because the median will exclude those a lot of times. All right, the next thing it says, if the data are categorical. Well, if the data are categorical, remember, we don't have numbers, we have categories. So if the data are categorical, you're going to need a mode for that. You're going to need the most frequent score, or the most frequent category that people mention. If I say I went out and I collected data on people's favorite type of pet, and I asked them, is your favorite type of pet a cat, a dog, or something else? And 10 people said cats, and 40 people said dogs, and 10 people said other. Well, the mode dogs would be the most common, and it would be categorical data. Okay. Now, if you want to do further statistical computations after this, then you're going to need to use a mean for that, because think about how many calculations you've learned already that involve calculating a mean first. For example, when you're doing a standard deviation, a lot of times we calculate the mean. And if you look at the long formula for that, it involves a mean. If you're looking for a a standard deviation of variance, even something like some parts of the weighted mean, for example, we need the mean of. The values are to be divided into two equal groups, one group containing larger and one group containing smaller values. Well, that's what the median does. It divides it in half. Half of the values are below the median and half of them are above the median. So that's the median category. Okay. I hope that this discussion has helped you, and I will see you very soon in my next video. If you have questions, please don't hesitate to ask us. And I hope that everyone is doing well today, and I'll see you in my next video very soon. Thank you, everyone.